Yes. Uh, a very good morning to one and all. I welcome you for all to the International Conference on Artificial Intelligence, Communication Technologies, and Smart Cities Conference. It is my great pleasure to invite Dr. Vasant Matsagar, sir, for this conference, and we are privileged to have you here as a keynote speaker. Let me give a brief introduction of Dr. Vasant. It is an absolute honor to introduce today's keynote speaker, Dr. Professor Vasant Matsakar. He is a visionary leader in civil engineering, multi-hazard protection, and structural dynamics. He currently serves as Professor, Dogra Chair, and Head of the Department, Civil Engineering at IIT Delhi. Professor Matsakar earned his PhD from IIT Bombay, where his groundbreaking research on earthquake-resistant structures earned him the prestigious IIT Bombay Research Paper Award. His postdoctoral work at Lawrence Technological University, USA, on CFRP composites in pre-stressed concrete bridges further advanced structural resilience. With over 164 international journal papers, 147 conference publications, and multiple books, his research continues to shape the future of civil engineering. His expertise spans multi-hazard engineering, vibration control, and fiber-reinforced composites, leading to the patented technologies implemented in real-world projects across India. Recognized with numerous prestigious awards, including Fulbright Palam Climate Fellowship, Humboldt Research Fellowship, and IBC Award of Excellence in Built Environment. He actively contributes to setting engineering standards for BIS, IRC, and ISO. Beyond academia, Professor Matsagar serves as editor-in-chief of the Indian Concrete International Journal and holds key position in research and engineering societies, including vice president of ISET and founding director of CBS. His extraordinary contributions continue to inspire engineers and future innovators. With great pleasure, I invite Professor Dr. Vasant Matsagar to this conference. Please join me in welcoming him on this session. Vasant sir, you can take over the session.
Thank you, Spurti. Am I audible to you all?
Yes, sir, you are audible.
Okay. And let me put the conference background first. Are you able to see the conference background? Kindly unmute me. Am
Sir,
I
you are,
audible?
yes, you are audible. Yes.
Is my background
Yes,
mirrored
yes.
or it is straight?
No, it is straight, sir.
Okay.
Yeah.
Please allow to share my screen.
Sir, you are given the presenter access.
Okay.
Yes.
Is my screen visible?
Yes, sir, it is visible. Yes.
Are you able to see my slides?
Yes, sir, it is visible.
Okay, wonderful. Hey, good morning, everyone, once again. And it is my proud privilege to interact with you on the platform of International Conference on Artificial Intelligence, Communication Technologies, and Smart Cities. And my talk exactly revolves around all these aspects today. Before I begin my discussion, I would like to know from Spurti as to what is the time availability for me.
Sir, you can take a session for 20 minutes.
Okay. Okay, so once I reach to 20 minutes, please let me know because I have many things to talk about on exactly this topic. So I
Okay,
may
sir,
exceed
sure.
my time. So
Sure, sure.
in order to conclude my presentation in time, please let me know.
Sure, sir, yes.
Okay, my talk is revolving around the exploring contemporary themes in smart cities, a structural engineering perspective. And during the introduction of the speaker, Spurti has mentioned some part of it, which we have been working since last now more than 2 decades. And I will highlight some of those parts. Initially, I'll introduce you some concepts. Again, I will not take much time in there, and then I will immediately move on to what are the uh, activities across the world around development of smart cities. Subsequent to that, I'll show you as to what kind of research we are doing at IIT Delhi, and I'll connect that with the current ongoing efforts being made in India on development of smart cities and how Bureau of Standards is bringing in. And of course, all this I will give from the perspective of structural engineering. And in particular, as you must have heard during the introduction, I work in the area of multi-hazard. So I typically put that as multi-hazard resilient community. During this discussion, there are several terminologies used, and I wanted to ensure that those terminologies are fully understood. One terminology that is used is hazard, and hazard is again a mathematical quantity. It is quantifiable depending on which hazard that we are talking about. But in general, hazard is such an event which potentially cause harm to human life. It has a potential to damage structures and even the overall environment. Hazard could be of large number of types. They could be man-made, and they could be triggered from some natural events such as earthquakes. The man-made events are also sometimes called accidental events. It might be because of some accident that happens, and sometimes even the natural events such as earthquakes or tornado, tsunami, they directly may not affect the human life as such, but because of our built environment not so properly designed and constructed, they may also pose a threat, and that is how it would cause a hazard. But hazard in itself does not convert into disaster or calamity depending on where it happens and how much is the exposure to the population and the built environment. A hazard may or may not convert into disaster. Therefore, hazard is the event, and I can give example of the quantification. In case of earthquakes, we quantify hazard. For example, what is the seismicity level, what is the intensity, and how severe the earthquake may happen at a place. The other terminology that we use is disaster. Disaster is consequence of the hazard, and that consequence is in terms of how human beings are affected because of the hazard. Not all hazards may get converted into disaster, but those which are severe hazards, they only get converted into disaster or calamity. Now, disaster, the way it happens, it could be again triggered by accidental events in some industry or some commercial setup, or it could be because of the natural event triggered. And sometimes the natural event is so minimal, its intensity, the hazard is so low that it does not get converted into a disaster. So we distinguish between hazard and disaster, and we distinguish also as to what are the different kinds of hazards, and that is where during the introduction the speaker has mentioned that we are developing new technologies, smart technologies for resilience of built infrastructures against different kinds of hazards, and we develop protective structures against that, and that all research happens through multi-hazard protective structures laboratory at Indian Institute of Technology, IIT Delhi. Here we work mainly on two categories of hazards, and those are natural hazards and accidental or man-made hazards. There are a large number of hazards that could be categorized in either one of these, natural or accidental. However, due to all the constraints that we have in terms of infrastructure, in terms of space, and even in terms of time availability, at IIT Delhi, we are focusing on two natural hazards, and those are because of the wind hazard and because of the earthquake hazard from the natural hazards. From the accidental or man-made hazard, we are focusing on fire-induced hazards and blast-induced hazards. And from the blast-induced hazards, another hazard may crop in, and that is blast-induced ground motion hazard. So we are also focusing on that. However, these are not the only hazards that a structure experience, and depending on where that structure is located and how it is built and what is the exposure that it receives from different kinds of natural or accidental events, different kinds of events may happen and it may turn into disaster. Thereby, this presentation is only limited to which hazards we are focusing on, and the other hazards we are not much focusing. For example, tsunami hazard in our laboratory currently we are not focusing on tsunami hazard, for example. If we have a look at the Indian peninsula, Indian subcontinent, you will find that number of such natural events keep on happening. I happen to serve as a committee member in National Building Code of India. It was published in 2016 in two volumes, and in chapter 9 of that is completely devoted to the multi-hazard risk concept and multi-hazard prone areas. In that, if you see the sections 9.1 and 9.2, both of them are specifically focusing on multi-hazard risk concept and multi-hazard prone area. And it's a detailed document given by Bureau of Indian Standards, and in its volume 1, you will come across this map. What this map shows is what are the different hazards that are prominent across different parts of the country. And you can very well imagine that northeastern part is much more prone to earthquake hazard, for example, or northern part, northern belt, for example, bordering with Nepal here, the Bihar border with Nepal, which is all of us know as per the older code, it is in zone 5, that is much more prone to earthquake hazard. If we see some of the again northern part in either Jammu and Kashmir or Himachal Pradesh, Uttaranchal or Uttar Pradesh, they are also subjected to flood, and then floodplain again goes across towards Sikkim, Bihar, and West Bengal. Again, some of these areas are exposed to flood. I'm simply giving some examples as to what are those areas which are exposed to some of these hazards. If we see the eastern coast, particularly Tamil Nadu coast, you will find that it is exposed to tsunami hazard in particular as compared to any other place. If we see again the western part of India, for example, Gujarat here or the western coast of Maharashtra, it is subjected to much more wind loading conditions as such, similar to what we have in case of Orissa, where tornadoes or windstorms are much more prominent. So likewise, all across India, the Bureau of Indian Standards has looked into what different hazards are possible, and they have all been listed in here. Then in from our lab, we came forward to understand as to how these multiple hazards affect the built infrastructure. We have one publication in the current science for in open domain, which you can look into, on multi-hazard analysis and design guidelines, recommendations for structure and infrastructure system in the Indian context. Now here we have specifically mentioned what do you mean by multiple hazards or multi-hazard. These two terms are used synonymously or analogous, where we define that whenever there is more than one hazard affecting the built infrastructure, it falls into category of multiple hazards, and their occurrence is actually quite frequent. For example, there is about 19% of the world's land cover is subjected to single hazard, and more than 50% of the population is exposed to single hazard. But beyond that, if you focus into multiple hazards, 4 million kilometers square of the land cover in the world is exposed to more than one hazard, means multiple hazards or multi-hazards, and more than 800 million people are affected because of the multiple hazards. Similarly, if we see more hazards occurring at a place and affecting the built environment, the numbers are very, very high. And probably, unfortunately, the interacting effect between different hazards is not fully known, but they may have a cumulative effect. Thereby, we evaluate the risk that is posed to the community staying at a place. If I take example of, for example, as for the example, a particular state or a particular city or a particular region, then we find out as to how much is the population exposed to that hazard, what hazard it is, what is the level of hazard measured in terms of intensity, and then we see as to what is the building typology there, what kind of construction it is, whether it is brick masonry construction, reinforced concrete construction, or there are kacha houses or pakka houses. And based on that, we evaluate what is the probability of failure. And putting all this together, multiplying this, we evaluate eventually what is the risk. I can give simple example that if earthquake happens even of high intensity in an area which is not much habited, so in that case, hazard is higher, but habitation is lower, thereby exposure is lower. So typically risk might be lower. There could be a possibility that there is significant amount of population residing. However, it is not an earthquake prone area. So exposure is higher, but hazard level is lower. Still, the risk is lower. For example, there is an earthquake prone area, hazard is higher, there is a lot of population staying there, exposure is higher, but the building typology is very, very poor. It means they are highly vulnerable. So hazard is higher, vulnerability is higher, and exposure is also higher. And example is unfortunately National Capital Territory region of Delhi, where hazard level is significantly high. It is currently in zone 4. Exposure, a huge population is residing here in Delhi, and vulnerability also is not so low, though there are reinforced concrete construction. But overall, if you see the aging of structures, there are many structures which have been aged, and thereby the risk associated is significantly high in NCR region. So that is how we define the risk as the probability of defined harm or damage happening to a built infrastructure on human beings as a result of exposure to the hazard. Because of the risk associated, we distinguish between the direct losses and indirect losses, within which we have tangible and intangible losses. Tangible are something that is quantifiable. We can immediately quantify their effects in on economy, on medical rehabilitation, etc. Whereas in the intangible losses, we may not be able to immediately quantify them. For example, a loss of enjoyment in life, the sufferings that people have felt because of the risk posed to the community. So these days, most of the national courts are changing their design philosophies from the earlier deterministic analysis to probabilistic, and now from probability based to risk based design of built infrastructure. While doing so, we evaluate what are the site specific requirements for built infrastructure to be developed, particularly the smart cities, and for those smart cities, how they are exposed to different kinds of hazards. We categorize that into three parts: the cascading hazards, one hazard happening after the other in the second category. Non-cascading and non-correlated hazard, the first category, and the last category, the third category, is simultaneous occurrence of all these hazards, which are the concurrent multiple hazards. If you see it on the probability scale, these two events, event A and event B, it could be, for example, earthquake happening at some other point of time, and wind is happening at some other point. They are not correlated to each other, but please note that we are talking about the same structure during its service life of about 100 years. At some point in time it might get exposed to earthquake hazard, and some other point of time it is getting exposed to other hazards. In most cases, you would be aware that most of the design codes, they make an assumption that no two extreme hazards happen simultaneously, means the probability of occurrence of two extreme events happening simultaneously is zero. And that is where this first scenario comes into picture, that these two events, extreme events, are happening separately, and the structure is getting exposed to it, and therefore their probability is shown as probability of A event and B event as a separate event. However, I can give example of earthquake, and it is followed by a fire, and that has happened at number of places across the world, including in India. So because of the earthquake, there might be short circuiting taking place. Short circuiting may lead to fire incidents in that building, and then the building is engulfed in the fire. Now, without earthquake, that short circuiting might not have happened. Therefore, it's a conditional probability of occurrence of the event B, which is fire event, at the primary event earthquake has happened. So that probability of occurrence of this cascading event is expressed in this manner. In case of the concurrent event, there could be possibility of, first of all, low pressure areas develop, then wind starts blowing at a very higher speeds, and then it brings in clouds, and then there is heavy rain and thunderstorm, and that is followed by flood. Now that happens almost simultaneously, and therefore occurrence of all these different hazards, such as that because of the wind, because of the rain, thunderstorm, as well as followed by the flood. So there is no conditional probability. These are simultaneous occurrence of these events. Now their interaction is not fully known, but still, in order to develop the smart cities with our motive to make our communities resilient against different hazards, we need to understand what are their interacting effect and how they eventually affect the structure and what is the risk posed to the community residing there. Now, in order to evaluate that, we cannot simply sum up the risk. We have to evaluate it at each scale and how it happens over a different period, depending on what kind of structures it is exposed to. So there are a number of factors that we need to take into account while taking the risk-based decision making into account for development of the community. Again, I'm bringing your attention towards the National Building Code NBC 2016, chapter number 9.2. It has in that clause number 9.2 refers an annexure P. In that annexure, I have just taken one example. It gives a list of districts which are subjected to different hazards. So from that, we evaluate as to what are those different hazards that the structure or community is exposed to, and then we evaluate the risk. Now, risk evaluation frameworks are available in the literature. There are a number of such frameworks. Just for the sake of example, I have taken it from Hazard US. So Hazard US is hazards, and from the hazards we find as to, for given earth science hazard, how the risk is calculated, both in terms of tangible and intangible losses. I would again leave this with you to let you think on some of these aspects. I'll go forward, and then during the interaction session, I can again come back and discuss in more details what kind of risk evaluation frameworks are developed for built infrastructure. Multiple hazards are not fully understood by everybody, and therefore I have taken this one example as to how it is important to take into account the multiple hazard assessment of structures. This is a bridge that connects the two states, California and Arizona. It's a very busy bridge. I-10 bridge in 2015 has experienced collapse. Now that collapse has happened because of loss of the support at this abutment, and the abutment has been washed away by the flood, and that flood happened because of some heavy downpour or heavy rains in that area. So please note that the failure of the bridge has happened in a way because of the heavy rains, because heavy rains cause flood cause the erosion of the abutment, and then there is a loss of support and bridge has collapsed. And that is where I'm saying that multiple hazards, they may be correlated not in terms of their occurrence, but maybe in terms of the structure which is getting exposed to those kind of different events. Now all those processes are not fully known. How to model them is also not fully known. How they are interacting with each other is not fully understood. The data availability is also very scarce, and based on that, what kind of assessment we are required to carry out, what kind of framework we need to have in the designs, that is still not fully known. Thereby the multi-hazard assessment or multi-hazard risk assessment of the structures becomes extremely important um, for us to take into account while development of the built infrastructure, and to ensure that our new cities, modern cities, are safe for the communities staying there. And that is where the new innovations in the area of structural engineering comes into picture. Now, in
Respected
structural engineering, there are,
dear Vasant sir, can you come to the conclusion if it's
oh my
possible?
God. Okay, all right.
Yes,
I'll
please.
go a little faster as the organizers have mentioned that there is a short time available, but still there are about 28 slides left. I'll quickly come upon the main salient features, how we make the resilient communities in the smart cities. Resilience, we define how much time is required for recovering from whatever damage has happened because of the loss of functionality. And that is basically at the response and recovery level of disaster management. We do work on the preparedness and we do work on the mitigation. So this is a cycle in the disaster management, and yeah, in the multi-hazard resilient community in smart cities, we do follow this cycle and we have interventions done at all these levels. So they have been summarized here, and at IIT Delhi we have a number of projects, but I'm bringing your attention to one project which is SORTI, and I'll quickly talk about that project as to how we are putting together the framework immediately after the event, after any disastrous event, what kind of risk management we carry out, and how we have the rescue operations carried out, and then how we reduce the effects of or aftermath of the hazard on the community. So one example is shown here from the literature that when earthquake happens, the earthquake ground motion is propagated, and there are two waves that we understand: primary waves and secondary waves. The speed with which primary waves moves is much higher than secondary waves, and we have some seismic stations in the on the path of the ground motion, earthquake ground motion. They detect the primary waves. The signal is received in the control room, and then alert signal is sent to different stakeholders, warning them that as the P wave has arrived, there is an expected S wave to be arrived. Generally, these structures are more significantly affected because of the S wave than the P wave, and thereby we get an early warning. So these kind of systems are now becoming much more popular. In our smartphone, we get a signal that there is a possibility of occurrence of an earthquake, so that we can come out of our residences and go at the safe places. There are about 100 earthquake early warning sensors installed by Indian Institute of Technology, Roorkee, between the Himalayan region and the NCR of Delhi. You can see this is the Trans-Himalayan region, and this is NCR. A large population is staying here, and the distance here is not too high, and thereby the community here residing in Delhi are able to get the early warning of earthquake. With current technology, it is about few seconds, and of course efforts are being made by researchers to increase it. Now once it is increased, then how the digital innovation comes into picture for disaster management. For example, once that earthquake early warning system gives a signal, that signal is passed on to metro train, and for example the metros are stopped until the event happens. Or the traffic which is using the tunnel structures, the traffic is stopped, nobody is allowed to go in the tunnel, and once the event is over, then the tunnel is open for traffic. Similarly, in school buildings, in hospital buildings, in operation theater, construction activities, trains, industries, they can be halted. Signals can be sent as to how long the event would happen, when it would happen, and when it will be safe for us to go into our routine activities, for example, using the lifts in the tall buildings, etc. That can be done using the Internet of Things in the smart cities. So that kind of framework is being developed by different researchers. This is the global picture. How even the firefighting personnel are coming into picture, and what kind of signals are sent, how the police comes into picture, and how they work together to mitigate the effects of the different hazards on the community. So one demo project was carried out and digital innovations were introduced for disaster management in this. Again, due to paucity of time, I'm not going into detail, but the entire smart city can be made disaster resilient by putting together some of these analysis framework. So this is one analysis framework that is shown, and it requires huge amount of data as to what is even the people's behavior when any catastrophe happens, how people move across, and how we are able to take that into account in our design and planning of a smart city. Now, going much so into details of how the structural engineers take that into account and see as to how we make our particularly the tall buildings or tall infrastructure much more resilient against some of these events, whether that is because of the wind loading or because of any other hazard that they are exposed to. We evaluate the risk that is associated with it, and during the disaster event, how we ensure that there is almost no loss of people, no loss of life, and there is a minimum damage, if any, when the accidents of hazard happens, then the design level, the minimal damage caused to the structure. So we have developed some of these frameworks here, and we implemented here in multi-hazard protective structures laboratory in the Department of Civil Engineering at IIT Delhi. And one example from there is that of the sensor system for localization of trapped victims in collapsed infrastructure. Next month around this time, we will be having a workshop which will show you as to how these cyber physical monitoring systems are put in place in the infrastructure for multi-hazard detection, warning, and post-event assessment. And this is where we take our cities to smart cities. Cities are becoming more smarter. Thereby, the risk associated with people residing there is minimized as much as possible. There are a total of 5 bridges in which the sensors have been put in, and we continuously monitor them and try to evaluate what is the response of those bridges, even in the ambient conditions and then in the extreme event. Another framework that we have put together in which we are having smart devices installed. For example, variable dampers have been put together, and these smart devices in the smart cities, they help to make our built infrastructure smarter so that we have the smart community development in smart city context. These are based on the machine learning algorithm, and as you can see, this part of the sub-algorithm is focusing on the weighted random forest algorithm of machine learning, where we continuously gather the data and we change the properties of these control units in real time, and thereby we ensure that even during the disastrous event, there is no failure of the built infrastructure in smart cities. So this is the work which is already published. We have demonstrated this, and now we are going ahead to have its prototype developed, and that work is currently under process. On similar lines, earlier we have worked on the smart structures development in the cities with hazard resilient features incorporated. There is one building constructed in Noida, which is now being fully instrumented. And whatever earthquake happens and the response of the building, they are all measured. And then we compare that with our simulations, and we are ensuring that operational level of seismic resilience is achieved in this. So this is the scheme of the sensors and how the trigger happens and how the data is received and what kind of framework we have put together is summarized here in this. This is completely indigenously developed in the MHPSL laboratory of IIT Delhi. And there, our goal, there are 5 goals to reduce the risk associated with the human lives. We have also integrated that with the unmanned air vehicles and how they help in achieving this monitoring of different built-in infrastructure from the detection level, giving warning, and then post-event assessment. And then what kind of optimization we do, how we increase the response, increase the uh, uh, we reduce the time of response and reduce the risk, and how we increase the resilience of the community. Again, I'll quickly give one example as to how UAV have been put together. First of all, we worked on these objectives in the laboratory on cyber physical monitoring systems, putting the Internet of Things so that we collect huge amount of data, we process it, and then we have first of all shown it in the laboratory scale as to how it works and how we update our models and how we see the failure behavior of the structure. And then we create a local network by using drones, and with that local network we give warning signal to the community. So this is one framework which is developed in MHPSL, where we show that a person who is at work, for example in college, for example some students, and during that time there might be failure of the local network, and thereby we create a local telephone network by using the drones, and then the person is able to communicate, and with that smartphone we detect where the smartphone is, and immediately rescuers approach the person and evacuate the person and take him or her to a safe place. So that we have implemented in number of cases. We have also looked into when this failure happens. As you can see in this picture, uh, there might be some persons trapped under this, and we send these drones there, and then we decide a scheme of how to evacuate those persons from the built infrastructure, even when very severe earthquake or similar event has happened. So this has now been put together. We have demonstrated this, and in the event of any calamity like this, we are ensuring that all that cycle which I have shown of disaster management, we are ensuring the resilience of the communities. We have a consortium. There are a number of partners from Germany and India, where we have put together all the sensor networks so that we ensure that our cities are smart and our resilience of communities in the smart cities is very high. With that, I will conclude my presentation. My apologies for exceeding the time, but I'll be very happy if there are any questions, comments, suggestions on the work we are carrying out on smart cities. Thank you very much, one and all.
Thank you so much, sir. If there is any question, we have limited time. I would ask the audience to raise your hands, please, and I'll give you other access for your mic. Yes, Gajanan, sir, your mic is on. Ghanshyam, sir.
Uh, I am from Baroda, retired director of GSFC. I wanted to ask you this that in IIT Delhi, you have done a lot of things for evidence. How this has been utilized during the last 2 years?
Yes, very good question, sir. Unfortunately, the answer to your question is discouraging in a way. This has not been utilized. We have demonstrated this, and we are conducting a lot of stakeholder workshops. We are showing them that this is how it can be used, and only few people have adopted this technology from us. But major players in this, for example local authorities, municipal corporation, or CPWD or PWDs, they should come forward and adopt this. But as of now, no one has adopted this fully. Some public works departments have taken our help in developing their hospital buildings made out of base isolation, but that is at a very nascent stage. The one that I have shown using Internet of Things or cyber physical monitoring systems, that is yet to be adopted. Again, we have constructed one building here with fully equipped with the sensors and even the drone technology. It is for the demonstration, but people have to come here, they have to see it, they have to experience it by themselves, and then they have to adopt it. So as of now, that has not happened, unfortunately, sir.
But do we not have any marking or a points for the smart cities when they are evaluating such type of a thing they are adopting? If they are not
Yeah.
adopting, then negative marking should be there.
Yeah, you're right. So that does happen. So, for example, whether the sensors are installed or not, if those sensors are not available, then yes, they get the negative marking. And therefore, smart cities are, for that purpose, they are yet to be fully smart cities. Of course, there
Okay,
are efforts being made, but yeah, it will take some time
thank
unless
you.
the people like us are fully educated with these new technologies.
See, I am a technical advisor in fertilizer industries also. So I am
Yeah.
finding that how can we utilize your artificial intelligence in monitoring the fertilizer industries logistics also.
Okay.
That is
Okay.
also the thing I am
Yeah.
suggesting.
Very good comment, sir. Now I will give one more example that one of the industry partners here in the NCR, they approached us for similar purpose. Of course, the requirement was different. It was a petrochemical plant, and there was a possibility of accidental explosion, and they wanted to make use of some of these technologies in that industry. And based on their local needs in that industry, we evaluated what is the risk, and then we put together a sensor network system there to make it kind of a smart industry campus. Just to give you one heads up on this matter.
Thank you very much, sir.
Sure, sir. Welcome.
Thank you, sir, for answering to the questions of audience. Sir, now I'll be sharing my screen. Sir, on behalf of everyone present, I extend my heartfelt gratitude for your insightful keynote address on disaster management and risk management. Your expertise on multi-hazard engineering and structural resilience has provided us with a deeper knowledge and deeper understanding regarding the current technologies which are available. Thank you for sharing your invaluable knowledge and experiences with us. We sincerely appreciate your time and your effort for enlightening us in this session. We look forward in learning more from your work and in the future. Thank you so much, sir.
Thank you so much.
Sir, now I would like to request everyone to kindly turn on their camera so that we can take a picture. Uh, all of you, I request everyone to turn on their camera.
Spurti, others may not have the permission to turn on the camera.
Okay, just one second.
Good morning, Professor Delhi.
Hi, good morning, Professor Vasant.
Good to see you.
Yeah, good to see you too.
Okay, I think we can get started on the session 2. Welcome, Venkata sir, for the second keynote session. Gives me an immense pleasure to welcome Professor Dr. Venkata Santosh Kumar Delhi. He is an esteemed academic and researcher in the field of civil engineering. He is currently an associate professor and Anantrao Jagpat Chair in Construction Management at the Civil Engineering Department, Indian Institute of Technology, Bombay, with a BTech in Civil Engineering from IIT Madras and a PhD in Building Technology and Construction Management from IIT Madras. Professor Delhi has made significant contributions to research and education in construction management. His areas of expertise include infrastructure project governance, construction project management, organization in construction projects, infrastructure sustainability, and structural engineering. With over 19 years of teaching experience, he has been instrumental in shaping future of construction management and infrastructure development. Professor Delhi's work also extends to emerging technologies such as building information modeling, BIM, artificial intelligence, AI, and machine learning ML in construction domains, including safety management and contract administration. His contributions continue to impact both academia and the construction industry, making him distinguished figure in the field. It is my great privilege to invite Dr. Venkata Santosh Kumar Delhi to this session. Please join me in welcoming him. Santosh sir,
Thank
you
you.
can kindly take over the keynote.
Okay, thank you. Let me just see if I'll put on my presentation. I hope you can see me first thing. And let me see. Okay. Can you see the screen now? Spurti, can you just confirm whether you can see the screen? Okay. Okay. I hope I'm audible and my screen is visible. So let me just quickly take you through my take on smart cities and how the advent of these very interesting technologies like AI, ML, how are they changing the landscape of construction and infrastructure development, especially related to urban infrastructure, which will become the heart of any smart city. So that's purpose of it. I've by purpose not included a lot of math, a lot of formulae or any such things in this presentation. And I hope that the purpose and philosophy of why we adopt different technologies for and what is the need to adopt such emerging technologies in construction. If that message goes across, I think the purpose of this presentation is served. And therefore, we will just look at an overview of how things are changing and where does AI ML has taken over already, where they are poised to take over in the entire construction project lifecycle. Okay, so just in case if my audio video is not visible to any of you, this is me. You can also contact me at that email ID if you require it. I teach at Construction Technology and Management Group of Civil Engineering Department at IIT Bombay, and I would restrict this presentation to about 20 minutes as requested for Professor earlier as well. And we will see if we can have scope for a few question and answers. So just to give you a basic background, why we are looking at many different things, right? I mean, if you look at it, the contribution of our, so just to put a very big perspective, um, our urbanization, as you all know, is increasing a lot, and therefore, what happens is the kind of energy which comes out of that usage of the buildings and infrastructure in an urban setting is quite substantial. And as you can see, there is an increasingly urbanizing trend as per various reports, and therefore you also see a number of things happening. ACs which were not really a forte of Indian community earlier has become a very um, uh, essential and fundamental things to many dwellings and households across different spaces in India. So what you see is that slowly the dynamic of city, the dynamic of the environment surrounding the urban, you know, ecosystems are changing a lot. And with the advent of a lot of technologies, what we also see is individuals are spending a lot of time indoors compared to the normal societal dynamic earlier, where humans were considered to be social beings, but increasingly people are becoming social media beings, and uh, they are forgetting socializing. So what you are seeing is that in fact, if you look at this conference, we are doing it. Uh, I am sitting in my own office. You are sitting in your own offices, and then we are all coming together through digital technologies. So that's where the dynamic of the the life, especially in the urban spheres, have changed a lot, and we are increasingly becoming reliant on digital technologies, and we are also becoming increasingly more space centric, and therefore the importance for looking at ways in which we can do this, ways to make our cities smarter so that they respond to their living spaces. And also, in order to achieve that, what do we do when we create such cities? So that's the primary motivation, with many different technologies which are coming into construction to make our which usually get morphed into saying that our construction has to become smarter, faster, cheaper. All those cliches apart, I think the primary motivation for us to understand is, can we have our construction intelligent enough to create these smart cities? Now, I've used two important terms, smart and intelligent. It's a matter of debate what is smartness and what is intelligence. But I will like to touch upon one of that debate, and then we move forward from there. So, what is intelligence is the primary motivation, and we'll understand how that intelligence is translated into civil engineering, into construction. The earlier speaker, Professor Matsagar, has given a great introduction of how AI ML and how some of the algorithms are being used for risk and hazard assessments, and making our life more safer. So we go in a similar vein, and what we kind of understand is how do we make our construction processes, construction technologies itself a lot intelligent, so that we achieve all these huge goals we have set ourselves as humanity, as a country. So that's the idea. So I'll just briefly touch on this, what is intelligence, and then we move on, what are the technologies which are really taking us, the construction industry, by storm nowadays, and where are we in terms of adoption there. So if I go into the very notion of intelligence, there are many definitions, of course. As we are intelligent beings, we tend to give out many definitions. But I think this is one interesting way in which we can think of what intelligent means is, um, you catch up, you make sense, you figure out. What does that mean? It means that you tend to learn. That means uh, intelligent system, an intelligent process has to learn from experience, has to, in a sense, make sense of what is happening around it. And the third, and I think the most evolved form of intelligence, is to figure out what is happening and solve it. So just to understand a little bit of it, when you start learning from your experiences, that is one way of saying that it is good or bad. You tend to classify things. You tend to say, okay, when the similar situation arises in future, based on your experience, you have learned from your experience, you tend to do uh, whatever is best for you. So in a sense, the machine learning algorithms, what we see are those learning algorithms. So that is why it's called learning, machine learning. So a machine is learning from not just its experience, but experience of a lot of individuals. And that is why you call that a machine learning algorithm. So a machine learning algorithm, for example, takes experience of a number of individuals whom we call now the big data or the data points, where you have ground truths, where you say, okay, I'll give you a very simple example. For example, if you say, if you close your eyes and walk, you hit something, and what happens is you create a lot of data points where people hit different things when they walk with their eyes closed or eyes open. So then the intelligence is to learn that at this point in time it's a bad idea to close your eyes. So that's intelligence. Now making sense becomes a little bit more or in a sense, for example, in learning is like, for example, uh, you know uh, when you learn that you have to go out when there is light, it's bad to go in dark. So that is essentially the learning process, where you say that, okay, when a situation comes, I will look whether it is dark or bright. Only when it is bright I go out. So this is probably what maybe the early humans have learned, why to stay in the home in caves during night and go out to hunt in the morning. So something like that. Now it requires a little bit more intelligence to make sense out of it. For example, to understand um, you know why it is important to go in a sunlight, or what causes brightness and darkness. So that's a big problem to solve. So to learn is easy, to understand is a much difficult problem, because now you have to make sense of your surroundings and to understand that issue. So and then the final and the biggest issue would be to figure out. That means to solve the problem of darkness. Now that becomes a bigger issue of intelligence. So if you look at the state of art AI/ML, we are we have state of art in terms of learning. We are seeing glimpses of understanding now. Okay, solving is some time away. So you have to understand this. It's very important, because that's where AI, ML, and so essentially AI, when you talk about intelligence, machine learning, or all these kinds of algorithms, what you see around are the basic learning algorithms. But then understanding algorithms and solving algorithms are some time away. Understanding, we are seeing glimpses of it through large language models. What we are seeing now, I think that the popular name for a large language model is GPT, Chat GPT. You all might have used that. Now there is a DeepSeek algorithm which has come. Um, in the vision world also, you have very interesting challenges where you say that, can I check whether there is a human being in a picture, right? So these are the things which are coming out. Now it takes a lot of time for systems to come up to that learning stage. It took a lot of time for people to actually create algorithms which can really learn. But we have seen a very increased acceleration of these learning algorithms, and now you are actually seeing in a very short span of time, compared to the time which took for people to create learning algorithms. Now that is the interesting part, where we are seeing it, that it's getting accelerated, and now people are actually um, researchers are tending to give you glimpses of algorithms which can understand. Now, therefore, if you look at the acceleration which is happening, we are not a lot of time away when the algorithms to solve things can start happening. So that is the exciting world of artificial intelligence, which I want all of you to understand. And I think as construction, as one of the oldest engineering disciplines in the world, we cannot be left behind. And what you see is we are not left behind as well. We see a lot of things happening in construction. I'll give you a little bit of a glimpse. And the first and foremost thing for us to catch up into this intelligence wave is to digitalize our entire processes, because a lot of things happen manually. And if you don't have the internet of the world, if you can't have a lot of repositories of digital documents, you cannot have a large language model which can read the entire internet and give a chat gpt to you. So the digitalization becomes the core for any sort of development of ai ml in this space. And therefore the first and fundamental process what we have to do in construction is digitalization. And that's where a lot of research happens nowadays. And we have clubbed a lot of things together in what we call the industry 4.0. Now we are moving into what we call industry 5.0, but let me tell you a little brief on this. So the basic ideas of the industry 4.0, or translated to construction 4.0, are interconnectivity, information transparency, and decentralized decisions. That means that you have to have a lot of IT and digitalization based support to construction and digitalize the processes. So that's the key term which comes out to make our constructions intelligent is digitalization of these technologies. So let me give you a very brief overview of how many technologies are right now being utilized to help us to achieve this idea of um, digitalization in construction. I think the building information modeling, which is almost at the forefront of digitalization technologies in construction, BIM, if you look at it, BIM has evolved from late 80s, 70s. There are always digital tools for design. Uh, but the visualization and the 3D and the 4D portions and the information models have developed rapidly over the last few years. And now you see that BIM is quite mature. We see increasing adoption of BIM across projects, not just for visualization. Predominantly, it was there to visualize how a 3D space looks like, and therefore found a lot of interest in the architectural community earlier. But now, because of the databases which BIM has, therefore, I put that icon of a database rather than for a visualization of a building. That database is becoming very, very important for construction and construction managers to actually make their constructions digitalized and intelligent. You now have a lot of cloud technologies. You have number of nice connectivity. Therefore, that cloud processing and that has come to help a lot. IoT, as again, very well nicely elaborated by our speaker earlier, has come into earlier, but IoT is being essentially being very much used in construction as well. Lot of your construction equipment are coming with IoT devices. A number of technologies are now to help in terms of material location, productivity measurements, efficiency measurements for IoT. And it has a huge implications in terms of safety on the construction sites as well. Most of you might have heard about this interesting technologies of 3D printing, the idea of robotics coming up in construction. So those are all very, very exciting fields which are driving us more towards quality construction and maybe utilizing the time of our construction engineers and the construction workers in a much more efficient manner than what we are doing today. So there are other technologies. I would briefly touch on that. So I will give you a life cycle. So how does these technologies come together? There's a lot of these technologies should talk to each other in order to give you this highly important intelligent construction. So and this should happen throughout the life cycle of the project. Sorry for the typo there. The project life cycle in order to achieve your construction, and some of them during construction, and some of these technologies which will translate to digital twins often form the basic core of a smart city. Because if you want to have a important smart city which can really facilitate have dashboards of what is happening at different locations, etc. The digital twins which in real time capture these technologies, what is happening, data from different buildings, different infrastructure, built environment, form the core technologies. So that is why it's very important for us to digitalize these processes and come to a facilities management kind of a digital twin, which will then be integrated into urban spheres. So let me quickly give you, I will go through these things very quickly for want of time. I know at some point I will be stopped by Spurti. So BIM generative designs are essentially a lot of things are happening in the generative design space, where earlier, if you have to evaluate about a 10 or 15 kind of designs, nowadays there are tools which can evaluate millions of concepts so as to get you the right shape, the right form, the right space for your requirements in a much more energy efficient, sustainable manner. So you can have these realistic 3D renderings. I think this is the most trivial part of the digitalization aspect. Um, we are now not going into 2D drawings at all. You will see pretty soon the 3D models along with AR, VR can happen. So this is a walkthrough which has been created by some of our students. And I will tell you, the once you have your drawings ready, this walkthroughs don't take a lot of time nowadays. Okay, this took about 30 minutes for our students to just create this. Okay, so you are in a world where you can visualize this technology is much better. Now, one important thing where it is very important for us, where a lot of rework happens is when there is a constructability issue, where your services clash with your structural elements, etc. Nowadays, we can do that on the site even before you go there. Okay. So there are other dimensions of BIM, cost, energy, and there is no limit to it. That's my whole idea. So there is no limit to the number of dimensions, because you have a nice database, you can go ahead and do it. So I'm just giving you a glimpse of what generative designs can do. These are some of the projects of lighting, the space, the network optimization for piping, etc., which can be done very nicely nowadays with these AI ML algorithms. So, so the general philosophy is again this thing. I'm not going into the generative design philosophy. Now, the technologies have come up to very interesting phase where you can also look at augmented reality applications. So this is for example, way in which this is a prototype AR or based application which runs on your mobile. So that's the power of which is powered through AIML, where you can think of how to place your temporary facilities, such as your batching plants and material storages, etc. This is again part of a research by one of the students here, but it's quite amazing things what things can do today. Just then there are safety based applications, so you can see a lot of safety based training programs, like which will give the workers understanding of the safety is. There are gaming programs which are nowadays as part of it, where you can really look at these are all glimpses of research from the lab here. You can also create virtual installation mechanisms so that people understand it. You can train people. Nowadays, there's a training module which we have developed where people can get trained for one-off construction sites. Like, for example, if you're doing in an offshore underwater, there is a repair which you have to do. The virtual reality application can help you to understand how you have to go through it. before you actually dive into it, where there is that thing. Now the
Excuse
last
me, sir.
question.
I
Yes.
would like to request you to conclude the session,
Yeah,
please.
so exactly. So I was afraid of it. So this is the last part of it to understand. So understand is the biggest question right now in AML community. We are, as we said, we are seeing some glimpses of it. Now we are going into what we call
I hope my
the
screen is
explicit
visible to
information.
you.
Uh, I hope my screen is visible. Yeah.
Yes, sir, it
So
is.
what?
It is.
Yeah. So the digital twin maturity models, etc., are now coming up. So what you see is the integration of AIML in not to just gather data from buildings, but also to understand and kind of take decisions on how do you actuate certain things on the buildings so that they can really serve the purpose and become energy efficient, etc. So there is a lot of things which is happening. I hope. I am not going into all these slides as I can understand there is a lot of research which is happening in this direction nowadays. But the key question which I would like to leave you all is, and this is something which we'll have to understand, shall we take this road of AML at all or not? This question is moot now because AML is anyway going to be there. The key question is how do we suit those technologies to our projects best? Because some of them can cost you a little bit right now. So are we ready for it? Are our organizations ready for it? Are our processes ready for it? So that's something which we have to look forward. There's a lot of research in this direction. I hope some of you or all of you can take up some topics related to this construction and to make to make our construction more efficient and better for future. Thank you. I acknowledge all the other where faculty and researchers from where I've taken some of these things. Thank you. I'm open to a few questions. I'll stop sharing
Uh,
now.
Thank you so much, sir. But due to limited time, we will not be
I
able to
understand.
take questions. So,
Okay.
sir, uh, sir, it was an immense pleasure to have you as the keynote speaker for our conference. On behalf of everyone here present, I sincerely thank you for for this enlightening keynote on intelligent construction and how AIML are changing the landscape of construction and infrastructure development. Your insights into AI-driven innovations, predictive analytics, and automation have given us a deeper understanding of the future of smart infrastructure, and your expertise has been groundbreaking contributions, and I am sure that it will continue to inspire the industry. We truly appreciate your time and effort and for sharing your valuable knowledge with us. We'll be looking forward to see these advancements that can shape the future of construction. Thank you so much, sir.
Thank you. Thank you very much, and all the best for your rest of your conference.
Thank you so much, sir. Uh, Uh, Last time we were not able to take a picture, so I would be giving you the camera allowance. So I request everyone to kindly turn on their camera so we can have a picture. There are still some contestants joining, so I request everyone to kindly turn on their camera, please. Thank you so much, everyone. Thank you so much. Now I would like to request our third keynote speaker for the session.
Yes, I'm here.
Yes, sir. So just give me one moment. Yes, for the third keynote session, we have with us Dr. Saiful Amri Maslan. It is an honor to introduce today's keynote speaker, Professor Dr. Saiful Amri Maslan, a distinguished expert in smart materials, magnetorheological MR technology, and semi-active suspension systems. His groundbreaking contributions have significantly shaped the future of automotive and structural engineering. He is currently serving as a professor at MJIIT, University Technology Malaysia, UTM. Professor Saiful holds a PhD in smart materials from Dublin City University, Ireland, along with engineering degrees from University Kebansan, Malaysia. His credentials as a professional engineer, professional technologist, ASEAN, CPENG, and APEC engineer reflect his esteemed standing in the global engineering community. With over RM 13 million in research grants, 12 granted patents, and more than 6,500 citations, his pioneering work in MR materials has earned him numerous accolades, including Best Paper Awards and Outstanding Achievement Awards. Beyond research, he has supervised over 35 PhD and master's students and played key leadership roles at UTM. His global influence is evident through collaborations with leading institutions in Europe, the Middle East, and Japan. A sought after speaker and technical expert, Professor Saiful actively contributes in research evaluations, technical panels, and journal editorial boards. His dedication to innovation and mentorship continues to inspire engineers and researchers worldwide. It is my greatest privilege to invite Professor Dr. Saiful Amri Maslan to this session. Please join me in welcoming him. Sir, I would
Okay,
hand over the
thank you,
session to
Miss.
you.
Okay, thank you, Miss Spooty.
Thank you
How
so
do
much, sir.
I share my? Mm, I'm not sure how to share the content. Let me see.
Sir, on the top, you will find a button called Share,
Yeah,
and there you can share your screen or your window or a particular window that can be your presentation as well.
I cannot click this one. I don't know why.
You have been given the access as well, so I don't think so that will be a problem.
Oh, okay.
There is some technical difficulties from the session keynote speaker. I would request everyone to just have patience. Last.
Okay, can you see my presentation slide?
Yes, sir, it is visible.
Okay, you can see that, You can hear
Yes,
me.
yes.
Okay, thank you very much.
Yes.
Okay, now, I'm very sorry for the this thing. Okay, this is my title about the unveiling of the world of MR material. MR stands for the magnetorheological fluids. Sorry, magnetorheological material. Okay, I don't want to talk much about this one. Okay, as a basic one, I'm from University Technology in Malaysia, Kuala Lumpur, and we have 3 UTM in Malaysia. The main one in Johor Bahru at the south one, and then the Pago and Kuala Lumpur. Okay, you can see this is my faculty, Malaysia Japan International Institute of Technology. Really, you can see there is a KL, the tallest twin towers in the world, and then beside that we can see the KL Tower. Okay, this is my faculty. Okay, we have a lot of collaboration. That's why we call it Malaysia Japan International Institute. We have about 30 university institute in Japan that collaborated with us. Okay, now why I choose this topic? Because of this kind of thing. You can see on the left, on the rough terrain, the suspension, they really need a very soft one. And then on the right side, we really need a hard one actually. So we have a two type of terrain. Then how to accommodate types of the by using a single device. This is where the MR paper comes. And then the basic of the MR methodological, where we can adjust the stiffness of the suspension from hard to soft using magnetic field. So you can see on the right graph here, when the off state, meaning that when there is no magnetic field, it act as a normal damper or normal. But if we increase the current, we can see the damping properties will increase. So that become very hard. And then we can enlarge the damping according to whatever the input come from the road condition. Okay.
Saiful, sir, there is some audio issues from your end. Excuse me, sir. Saiful, sir, there is some audio issues from your end. Actually, we are not able to hear clearly. Hello, am I audible?
May I proceed?
Yes, yes, please, please.
Okay. Okay, for MI divisor, normally we can the main one we can divide it into 4 categories. Number one is smart infrastructure and adaptive building, where they will cater for the seismic protection and the vibration control. Number two, intelligent transportation system, where the MR suspension is used in the vehicles and traffic control. And then we also can go for the energy efficient and sustainable solution, where normally wind and vibration energy harvesting, smart windows and facade. Even though for the we can enhance the safety of the shock absorbent in the infrastructure and then wearable safety devices. This is for main category. Few example for the number one, smart infrastructure and adaptive building. We can see one of the building in Japan, Yokohama Landmark Tower. They put it this damper for the seismic condition, where it can adjust. It depends on the what is the input. what is the vibration coming in and how they damp all the vibration. And then if you we can see that the bridges, one of the bridge in China, Dongting Lake cable stay, they put it the damper here. These two damper are tied into the cable. So this kind of tool for the smart infrastructure. Okay, for the intelligent transportation system. Okay, on the left side, this is normal car, and then we have all four suspension. Even though this is already commercial, they call it magnet suspension, where they have the system and then the suspension independently, and then it can respond to the road condition. On the right side, this is from the road corporation. They changed to the Parker company. They call it, okay, they have three types of the suspension. They have the seat suspension, they have the cap suspension, and the prime one is the normal suspension, that the MR fluid. Okay, and for the energy efficient sustainable solution, this is for the wind turbine where they put the damper there to harvest the energy. And then for the enhanced safety security, we have two type of the thing. They say on the left side, the MR brake. This is for the foot orthotics when they can hold the leg and to release that one according to they can assist the patient. And then for the MR train brake, actually this one is they utilize the MR damper for stopping the train, and they use like Shinkansen in Japan. And then other potential of the application, you can see there's a lot of the research that you can see MR enhanced cache barriers. You can utilize in highway smart roads, blast resistant MR walls, military and embassies, something like that. This is for the, and then MR based motorcycles. Even though this is a helmet, they will utilize a kind of the MR, and the MR infused body armor. This is normally for the reuse. MR based emergency brake. This one good for the autonomous vehicle. Blueproof when there is a hit or there is a MR based smart locks. This is for the security. Okay. Before I go further, just to introduce you that I am from this engineering material structure research group. We have about only 6 people, and we have a lot of the master and PhD students. So you can see me and then another 3 lecturers. They have their own expertise, and then 2 postdoctoral that working with us. We cater for the material development and characterization, MR design devices, materials, durability. The recent one, we try to penetrate the 3D printing, where we can change the 3D printing to 4D printing. Okay, actually what we want to do is to develop some material for the tunable radical properties that we can control the material by using it. The field, this one of course, because we have a lot of the vibration, we want to cater for this one. And then how to get the magnetic field is by the magnetic field generation. This is looks like simple, but we have a lot of the design. Okay, under the MR material, actually basically we have 5 categories that we have. The fluid one, it's like fluid, and grease, slightly thicker than fluid. We have the plastomer, thicker than grease, and is something like semi-solid. And the MR foam, very soft, solid, and then MR elastomer. So this category, we are doing all the research in this all category, where we can see the basic of MR fluid, actually, how it works actually. When there is a magnetic field, the ion particle inside the fluid will respond with magnetic field and try to align according to magnetic field. So they can act as a barrier, then the fluid cannot go through. I mean, they can control the flow of the fluid. The best about this material is when we remove the magnetic field, you can see the particle will goes back to the particle will come back to the original place. Then this is reversible properties. So and the basic of the MR fluid, when we want to put it in the, we can have all the fluid, we can replace the hydraulic fluid, and then we can have the valve, then the MR fluid valve, when we can change the normal valve. Okay, this is for example MR damper. This is the very famous concept for the damper. However, for the MR fluid devices, there is so many challenges. Number one is the magnetic circuit design. For when we want to get efficient magnetic field, of course we have a very good circuit design, and then we are limited from magnetic saturation and of course the leakage of flux. And then number two, the fluid flow and containment. This one is designed for the channel geometry, sea leakage issue, and the most challenge is the particle sedimentation. I will go for this particle sedimentation because we have a lot of study on this one. It's very fundamental. And the mechanical wear durability for number three, this one related to the material selection, friction, heat dissipation. And then also power and control efficiency, where the electromagnetic design, control system combination taking over. And then the size weight constraint, this is another one because when we want to embed the magnetic circuit or electromagnetic, they will add the size to the original device. And then of course the last one, cost and scalability. This one because of the is quite expensive if we want to compare with the original one. Okay, this is some of the studies that we have been done. We have studied on the combination of the working mode. We have so many mechanisms. So this is one person that cater for this study. And then for the heat dissipation, we have to study effect to the device, even how it works. We have so many concepts for the one. Normally, what are all the device is already patented, and then we also look into the MR brake. This is we try to introduce here, and then we also have the valve itself. They have so many concepts where first one we manipulate the flow channel. You can see the 7 times plus that one for manipulating the magnetic flux itself, and then we also study on the modular MR valve, and then the MR damper. They actually this one for the one of the automotive manufacturer in Malaysia. We developed the damper for them. Okay, and then we also have the collaboration. This is with Charusa. I think you know this person. Your provost, he's the one we collaborated on this MR damper. Actually, we have the intention to supply for the military. So the design and the concept come from UTM and Indonesia, and manufacturing goes to Charusat to fabricate. They will cater that one and the testing. Now in the testing stage, and then you can see when Prof Fadi came to Malaysia, we have him, and we have the Indonesia. And actually this one all the alumni, where all my students actually they presented in one of the conference, and then they come from different universities all around this one Malaysia and Indonesia. Okay, now when come to the particle sedimentation itself, there is a lot of the problem, where the biggest problem is the sedimentation of the particle, because the density mismatch of the particle is quite big from the carrier fluid and the solid particle itself. So to cater this one, we have so many method to use that. But the normal one, normally we play with the type of particle. We have the additive, we have the non-spherical additive, we have the polymer coating, we have the particle size or shape, and the carrier fluid. Some of the works we do is the bidisperse. We try to mix the spherical and the flaky or plate-like shape. And then we also try to combine them but using the size micron and nano. Even though we have the durability, we have the device, valve, and then we want to see what will happen to the material for long-term operation. And then another type of the MR fluid, we have the MR grease. Okay, this one, I have a lot of students study on this one. We study on the biodisperse itself. We study about the size of the additive. I think quite similar with MR fluid, but actually they are different. And then we try to add many additive to enhance the performance or the MR effect of that one. And then of course we have the MRG devices where we study on the food autotic and MR break itself. And then we also want to know what will happen to the fluid or to the grease when we give a high temperature. And then we discover actually another category of the MR is we call it MR plastoma. This is quite interesting. You can see because it's like plasticine. The MR plastoma itself is unexplored and it's not famous right now. Okay, and then we also discover actually the conductivity for this meter is quite interesting. You can see a simple testing for this one when we can control the resistance of the current. Okay, when we put it there, you can see the light there from the bulb, and then we try to pull it, and it become lesser and lesser. This one, we explore the properties, but we still don't know what to do with this kind of the characteristic. Okay, another thing, we have the MR form. This is softer than the solid one. I mean the normal one. We have the challenge for this one because when they have a pause, they have the low strength, mechanical strength, they have limited magnetic response, the hysteresis and response also slow. This is 6 category, but we cater for number 1, number 3, and number 6. Where for the number 1, we try to put it the additive there, and then for another student study on what will happen if we try to fabricate the MR form using the constraint volume. And number 3, we want to see the magnetostrictive of this one. I will tell you the magnetostrictive study after this. And the other one, we want to see how we can use the MR form for the noise cancellation. Because it's very quite interesting when we have the MR form, we give magnetic field, they can change the structure of the pores. So maybe from the spherical shape into something like an oblong one, yeah, they can change, and then they can change the frequency, absorption frequency or absorption noise. Then we can something like can shift that one. Okay. The last one, we have the MR elastoma. This is quite famous one. However, they also have the challenge, low MR effect, modeling MR effect. We have the flexibility, strength, trade-off. We have the hysteresis, analytical conductivity, durability, aging, and the last manufacturing and scalability. So for the first one, actually for the low MR effect, we have students that study on. First, we try to coat the the iron particle using the polystyrene grafted, and then we also use what will happen to the waste tire, and then we also change the matrix to not only using the rubber, the natural rubber, explodized. We have the silicon, this kind of type. And then the last one, the fountain light. This is the one that we try to, when we want to fabricate the MR fluid, we have the isotropic and isotropic, where we can align the particle itself during the curing. So they actually affect the performance of the MR device. And then for the number two, for modeling, we have also few students that study on the normally for the machine learning and ANN. I think it's quite interesting to do this one. And then flexibility and strength, this one we try to add also additive, something like the CNT. We have the plasticizer. We also check on the what will happen to the particles itself because it's ion magnetic. For a long time, it become corrode. And then the last one for the silica nanoparticle, we want to study on the temperature stability. Okay, number 4 for the hysteresis itself, we try to put it the graphite and see what the electrical conductivity looks like. We have also introduced the cobalt nanoparticles. Sorry, the not cobalt particle because the cobalt particle itself they have the dual properties. They have the electrical conductivity and magnetic properties. Also, you can see the figure here. The magnetic restrictive actually, when we give the magnetic field, the MR elastomer itself, they will elongate. So you can see the difference in distance. This is actually for the sensor. So we have two students that one for the response, one to see what is the stigma, what is the metric for the MR elastomer that can change the I mean that have the highest magnetic restriction. And then for the aging.
Excuse me. I
Yes.
would like to request you to conclude the session, please.
Oh, okay. Thank you. Okay, the number 5. I have number 5, number 6. Okay, this is for the durability. We have the we study on the climate change, the tropical. We have we study on the what happened, the long term degradation, early stage degradation, and then we have to how to improve that, and then we have the cold or winter condition, something like we try to simulate. We have what will happen to this material when we put it in the salt water and then seawater. So this kind of thing, we as a collaborator from Indonesia and Czech Republic. Actually, this one from the Thomas Bata University. You know the shoes brand Bata actually that one comes from Thomas Bata. He's the one. He's the inventor for that one. They are quite good in the polymer studies. And then the last one, we have the manufacturing scalability. This is the device that we has developed. We have the MR isolator. This one for the building. We have the rubber bearing. And then for the automotive, we have the MR engine mount. And then we also study on the MR bushing. And then for the last one, we have the 4D printing. Actually, for the 4D printing, we try to fabricate the filament itself by ourselves because there is no existing available filament to purchase. And then we study on the VAT method and then the last one, the material extrusion. Okay, way forward, we have so many. We can divide into 6 actually because for the embellishment itself, we have another type MR 4D printing. So these are the potential research to study. Okay, with that, thank you very much. And then I pass to you. If you.
Thank you so much, sir.
Okay. Okay. Is there any question?
Sir, due to timing constraint, we won't be able to give the question and answer session.
Okay, no
So
problem.
for any questions, they can kindly approach you in terms of mail ID, if it's possible.
Okay.
Yes.
You can share my email.
Sure. Thank you so much. Respected sir, I sincerely extend my deep appreciation for your captivating keynote on unveiling the world of MR materials. Your insights into their transformative applications and in adaptive systems and engineering innovations have been truly enlightening. Your expertise and research in this cutting edge field have broadened our understanding and inspired us to explore its vast potential. We deeply appreciate your time, effort, and the valuable knowledge you have shared with us today. I thank you once again for your thought-provoking session. We look forward to work with you in your future advancement in this exciting domain. I thank you so much.
Thank you.
Uh, Thank you so much, everyone, for being present for the keynote sessions. I hope the keynote sessions have been useful for all of you. I would request all the participants to join their respective sessions, to join their respective tracks for your paper presentations at 12:40. So kindly, the link has been already provided to you guys. So I request everyone to join to their respective tracks. Thank you once again, and the timing will be 12:40. Thank you. You guys can leave the meeting.